Hi, my name's Matt, and I'm the creator of Math Inspector, which you're looking at right now. I created Math Inspector to be the ultimate math software. So it can do anything that other programs like Mathematica or Maple or MATLAB can do, except that it's based on Python. That's really the major difference between Math Inspector and those other programs. Those other programs have their own programming language that's proprietary and associated with them, and they cost money. Whereas Math Inspector is actually free. It's also open source, and it's based on Python, which is the world's most popular programming language, and Numpy, which is the fundamental package for scientific computing in Python. What really makes Math Inspector different, though, is that it has a block coding environment which creates a visual representation of the memory of the running program. Let's take a look at how that works. We're going to create a variable named x and assign it the value of 1. So in Python, just like in any other programming language, you do it like that. And as you can see, we've actually created this item x here in what I call the node editor. The node editor is great. You have this variable x, you can drag it around, you can pan, you can zoom in and out. It's an infinite zoom, so you can go as much as you want. And we can see its class is an int. We're going to use the keyword def to create functions. We're going to create a function f, and let's say that it takes as input a single argument a, and now we put a colon at the end and hit enter, and that starts a code block. You can see we have these 3 dots, and that's representing that we're inside of a code block. And so we need to indent. So I'm going to press tab, and this is a very simple function. So I'm just going to return a plus 1. And then I hit enter. And now it starts a new line, but I'm actually done with this code block. So without indenting, I hit enter again, and now the function f has been created. How cool is that? And we can drag it around. We could see what would happen if we evaluated f at 2. So we can just hit enter and we see it's 3, but the value of a has been set here to 2. And we can look at the output of functions by taking this wire and dragging it into the output area, which I think is pretty cool. And we can actually just come in here and edit it. So we could look at 22, right? And then what we could also do, we could plug x in, but we can look at f of x like this. And now it plugged the wire in for us. Now the way that Math Inspector does that under the hood is really cool. The way that it's synchronizing everything is really cool. What it's doing is analyzing the way that Python is interpreting the commands that you're giving it. And then it's creating this visual representation on top of that. So it's not changing how Python works, it's just giving you something on top. There's nothing inside the Math Inspector Python interpreter which is going to be different from a normal Python environment. There's some things you can do in the node editor which are kind of disconnected from the actual Python code which is underlying it. And you don't even need to use the interpreter at all. Math Inspector makes it really easy to save projects and then share them with other people. Let's keep exploring what Math Inspector can do for us. We're going to import Numpy. Now, this is normally going to be imported with an alias of NP. That's very standard, and in all the documentation that comes with Math Inspector, you're going to see NumPy has this alias NP. So when you import the module, you see on the left-hand side we have this kind of directory structure in the modules area. By the way, we have this object thing. The object debugger. We have X and we have F. Right now we have NumPy here, and so it's kind of organized everything for us. We have the built-in functions, which are things that are not written in Python, they're written in C++. Then we have the regular Python functions, then we have classes and objects, and then the submodules. So NumPy has a lot of stuff. And one of the things that's so helpful about Math Inspector is that you can look at the documentation. So here we go. This is the Math Inspector document viewer. How cool is that? You can see here it says that you should import Numpy as NP. It also has documents for everything that we just imported. So just to randomly pick one, arc cosine, it has this really nice document, and anything you click, you can use the arrow keys or the mouse to just sort through them. So that's the documentation system. Python's great because it comes with lots of documentation. And so Math Inspector doesn't require the internet at all. It's just using the documentation that comes with Python and parsing the text in the Python files and creating that beautiful documentation that you saw. Another thing that's really nice about this module view is that we have the ability to just drag stuff right into the node editor. How cool is that? So I'm looking for this. This is my favorite function here, Linspace. So what's Linspace? It just creates a regular interval of points of numbers. The best way to look at it. So now we have imported Linspace. You'll notice we can just type Linspace and we have this function up. I'm going to clear the console. So we have Linspace. And let's take a look at what Linspace of 1 to 3 is. So there you go. It's giving us 50 numbers between 1 and 3 that are evenly spaced, which is pretty useful. Now Linspace actually has some optional arguments which we can right-click on it and then show those optional arguments. Now these are not, don't worry about these ones. The number is the one that's really key. You can press the up arrow to bring back our last command, which is pretty convenient. And then this is the way, let's say we wanted just 4 numbers between 1 and 3. So there it is. You can see that the num has changed here. We're going to disconnect this wire. Let's take a look at what happens when we plot the output. So now we have this graph, and what's great about this graph is it has an infinite zoom and an infinite pan. You can resize the window, no problem. It's great. And even cooler, let's rearrange the windows a little bit. It's totally synchronized, so I can just come in here, if it'll let me, and change this to 10. Boom, there we got 10 points. And another thing that's kind of neat is we can animate. If you right-click, we can choose Animate. And that brings up the animation window. And now it wants to know what arg name to do. So let's have a little fun. Let's make it the start argument. And what we're going to do is we're going to start where we are at 1. And the stopping point is going to be at -3 to be symmetric. Now the delay in seconds, that's the delay in seconds. And the step, we need it to be negative. Let's go ahead and see what that looks like. You can see it's just really, it's animating it. By the way, this graphing system is built using Pygame, which is an open source framework for creating video games with Python. It's been designed with the idea of creating production quality animation, okay? So if you are interested in making your own mathematics or science education YouTube channel, Math Inspector might be the product that could really suit your needs. One of the things that is so great about the potential here is that it's an open source product. So if someone needs a feature, well, we can create that feature as a community and then make the product better for everyone. Let's go ahead and start a new file and find out a little bit more about some of the new features in Math Inspector Beta. The first thing I'm going to do is drag the console down and then bring up the Add Object menu by right-clicking in the node editor. This menu shows you all of the built-in Python operators, mathematics functions, built-in classes, built-in utility functions, and then here we have the Math Inspector examples. So what I want to show you right now is domain coloring. First of all, let's just take a look at what the output looks like. Here we have this really beautiful picture. Basically what's going on is the color represents the angle and the brightness represents the distance from the origin. I really encourage you to check out the video from 3 Blue 1 Brown for more information about domain coloring. You can see here I'm panning and zooming around. We can go zoom in really far and then it's going to get blurry and then kind of pop back in. And then if I try to move, it's going to be blurry and then pop again. Then if I wait a little while, it's actually not blurry anymore. Then if I zoom all the way out, it disappears. So the code that's behind how this is working is very technical because it's really computationally expensive to render an image like that. What's really cool about domain coloring is when we can start looking at what different types of math functions look like. Let's take a look at square root. I wrote this domain coloring function. If you want to know more about it, you can look at the source code by just right-clicking View Source Code. So what I want to do now is just show you what it looks like with the square root function. So let's zoom out and wait for it to load back in. Here we have our square root function. We can see it kind of changed the colors, which is a little weird. Let's take a look at maybe a different function. Let's maybe see the log function. I'm just randomly picking these. You know, it's a lot of fun to just play around. That's what makes Math Inspector so great. So that's really cool, right? Let's zoom in. This domain coloring is one of the new things that Math Inspector can do. In the old alpha version, we also had this complex grid. So I'm just pulling up the complex grid. Let's go ahead and take a look at what a complex grid looks like. So you see it's actually overlaying the complex grid right on top of the log function, which is still being plotted. That's cool, but wouldn't it be cool to actually show what the complex grid looks like going through the logarithm? So now, oh wow. Have you ever seen that before? Where you have these kind of grid lines on top of a domain coloring. Let's make it full screen just to really get how cool this is. Let me try and explain to you what we're even looking at right now. Each of those lines that we're seeing is how the log function has transformed the square grid. And what the domain coloring is doing is using the log function to compute the color of every pixel on the entire screen. I've created another new file here, and I want to show you how you can use Math Inspector to really easily save and share projects. The first thing I'm going to do is drag open the module view, and then bring up the project menu by right-clicking. And I'm going to choose New File and add a new file to the project. Let's call it video.py. And that's going to open the file you just created in your system's text editor. I'm using Sublime Text here, but you can use whatever text editor you want. You can see that video has actually been imported into the module area. And what's happening is Math Inspector is now monitoring this file. And anytime we save changes, those changes will be reflected in the node editor. So like before, let's create a variable x equals 1 and save the file. And we can see that x has appeared. And we can also say add 2 to x like this. And we can see that its value has changed and been updated to reflect that. And if we then change this, it's going to go back. And so each time we save the file, all the changes get updated in the node editor, and everything is synchronized. And by the way, if we had some sort of a weird syntax error like this, then the import is going to fail, and it's going to tell us the file and the error and the line number. And then when we fix our syntax error, everything will be imported properly again. We're going to start again. We're going to delete everything, and X is going to disappear. Let's create a really simple project that's going to show off some of the 3D graphics capabilities in Math Inspector. I would like to draw a helix. So the first thing I'm going to do is import Numpy as NP. And now what I'm going to do is define a function, helix, which will accept a single argument t, which is going to be an array of numbers, and then it's going to return np.sine of t, and then t, and then np.cosine of t. These are going to be the 3D coordinates for a set of points which are going to form a helix. And those points, let's call a capital T, is going to be this function Linspace, which is so helpful. And so I'm going to save the changes, and we can see that helix and t both appeared. So now what I'd like to do is compute helix of t in order to get those wires connected. Let's go ahead and see what the output looks like. And we can see right here that we have a helix. You can use the mouse and the keyboard to move around. So, okay, great. We have this really cool helix. But let's actually, instead of seeing points, let's see lines. So instead of returning a tuple from helix, what we're going to do is return a list. And that's going to tell the Math Inspector plotting function to draw a line instead of points. We can see we have this really beautiful helix, and we can fly around and we can resize the window. This is all done in OpenGl. And I actually love OpenGl. It's been really fun to code this out. And one of the things that's really hard in OpenGl is to get the lighting right. So I just want to show you, just for kicks, let's look at the cylinder. For the cylinder example, you can create these surfaces just like this. We can see that the lighting has actually been applied to this surface. And it's a very simple equation for the cylinder. You can find more information by looking at the documentation for the cylinder function. All of the examples come with documentation, and you can also view the source code. Okay, great. So we have our really simple helix, and we want to share this project. So before we share it, maybe let's create a README, a really simple README. I'm going to create a new file here, and I'm going to call it README. That's important. All right, so I wrote this README for our project, and now we're ready to save it. So to save it, just click File Save from the main menu. And I'm going to call this video in all caps, and then hit Enter, and it's going to save the project. So let's see what happens when someone else is going to open this project. And let's take a look at what the file structure looks like. So I'm going to start a new project. And now to open a project, I'm going to click File Open. And now we see that we have a whole directory. So when you share your projects, we're going to actually share the entire contents of this directory. And inside, it has a video.math file. It has the README, and it has the video.py source code file. So to open the project, we're going to choose the .math file. And the .math file contains the information for how the editor and all the parts of the app are configured. So we can see here that the README file opens right away. And that's what's so nice about having a README file for your projects. In this last section, I'd like to talk about how we can use Math Inspector to learn about Python and programming itself. I wanted to create a block coding system that could be used for Numpy. But in order to do that, I had to create a system that was at such a high level of generality that it would work for anything in Python. So let's learn a little bit about strings. I'm going to create a variable called string, and it's going to say hello. That's going to be our string. Block coding has become really popular these days as a way to teach people how to program. But Math Inspector is the only block coding environment which exists which is capable of mapping an entire programming language. Other block coding systems only map a small part of the programming language in which they were written. In order to get Numpy to have a block coding system, I created a block coding system for all of Python. And so if you want to learn more about Python and Math Inspector, one of the things you can do is look at the methods. When you right-click on any object, it's going to show you a list of all the available options, and I chose strings because they really have a lot. Let's just pick the first one and capitalize it. We can see that it comes back with this other string that's now capitalized, and that would be the same as running this command. So objects in Python have methods, just like objects in lots of other programming languages you might be familiar with, like JavaScript. But what's so nice is that we can actually see all the methods just at a glance. And if we wanted to, for example, just understand what are the available keywords in Python, you can right-click in the prompt area, and it shows you the entire list of all available keywords in the entire programming language. Another example of this is there's lots of operators in Python. We can take a power, 2 to the power of 3, just like that. And if we had a variable x equals 2 and y equals 3, and then we take x to the power of y, then it's going to also work and give us 8. Another way we could see that is by looking at these operators and then picking the power operator and then plugging them in. So if you want to know what is the list of all available operators, it's right there. All the built-in math functions that come with Python are right here. So we can get pi, for example. Then we have these built-in classes. Besides strings, we also have things like integers. Okay? So we can just look at the integer here. An example of an integer is x is an integer, right? So what other classes are there? Well, there you go. That's the list of all the classes. And then we have these built-in functions. These are really useful. Let's take a look at the absolute function. What we'll do is plug x into the absolute, and then we can look at the output like this. And then what it's going to do is it's going to take the absolute value, right? And that's going to be the same as calling absolute of x. Okay? So if you want to learn what are the built-in functions, they're all right here. And in terms of the documentation, we can really drill down into the documentation in a way that you couldn't before with the module browser, which is a really cool feature. I'm going to click Help from the main menu and then Browse Modules. So you can see here we have 2 menus, and these are all of the available Python modules on my system. And when you click it, it's going to show you the documentation for those modules. And actually, the way that I discovered how to write the interpreter was after I built this system. I found this module called code, and I started looking into all the documentation for it. So if you are unclear, oh, I want to import a module, but I don't know what modules there are, here's a complete list of every module on your system. There are so many other features in the new beta version of Math Inspector that we haven't even discussed yet. But this video is already getting pretty long. I am so excited about this project, and I really hope everyone loves it as much as I do. If you enjoyed this video, please subscribe to the channel and give it a thumbs up, and let me know in the comments what kind of features you'd like to see in Math Inspector. Okay, stay tuned for more videos coming soon. Stay safe out there, everyone. See you next time.